Good day, guys. We are looking at more problems on integration by parts. We already know that integration by parts. As I explained in my previous video, that's our formula for mathematics. That formula is on page number 4. Then you use elect to make your choice in place of F, and it will take the place of G. So that's my problem. My first target is to pick it out whether do I need integration by part. So to do that, check if I differentiate x, I will never get tan squared. If I differentiate tan squared, I will never get x. So that is how I know I need integration by part in a product. So from there, I have to choose one function as my f. The other one will be my g prime. So now to make my choice of who will be my f and who will be my g prime, that is where elect steps in. So that is elect. It is well explained in my previous videos. I stands for inverse, L up, the algebra, T, trigonometry, E exponential. So if you look at these functions, you see that x here falls under algebra, y tan square falls under trig. So in your elect, looking at it, it's obvious that as long as we're reading from left to right, algebra comes before trig. That tells us that algebra should come first. So that means in my formula for integration by part, I will say let f of x be equal to x, and that will tell me that the first derivative is a 1. And then that leads us to g prime. G prime means the derivative already is tan square 3x. That therefore means we need g. So to move from the derivative to g, we need to integrate. So to integrate tan square, it's a simple thing for a mathematics student. You simply open your formula sheet to page number 3 and look at the last formula at the bottom. So that last formula says the integral of tan square ax dx. For those who can understand it, you look at the last formula, you look at column number 3, the answer will be 1 over a tan ax minus x plus c. So that's your integral. So there our a, when we match it to the formula, our a is a 3. So if we apply that formula, it means the integral of tan squared 3x will be 1 on 3 tan 3x minus x. So that's our integral, and we can now substitute into the formula for integration by part. So if we substitute into that formula, the integral of x tan square 3x dx will simply be fg. You see here f is an x, the g is 1/3 tan 3x minus x. So if I multiply the 2, it means I'm taking x, I multiply by 1/3 tan 3x minus x, then minus the integral of f prime g. So your f prime is a constant. We practice sending all constant out. Then your g is that difference. So I'm integrating 1/3 tan 3x minus x. So looking at that, it's no longer a product because our f prime was a constant. We don't integrate a constant. So all I'm left with is to do this integral. So if I move on, I choose to open the brackets there, I'll get 1/3 x tan 3x, then this x multiplies there to give me negative x squared, then minus 1 into, I'm now integrating this. So to integrate to the first term, I don't integrate a constant. Now to integrate tan 3x, I go to page 2 of the N6 formula sheet. It tells me that the integral of tan ax is 1 over a being sec. So this becomes 1 over a. My a is 3, so it's 1 over 3 being sec 3x. So that's the integral of 1/3 tan 3x, then minus the integral of x, which will give me x squared on 2 plus c. So if I now remove my bracket, it means I'm getting 1/3 x tan 3x minus x squared. Then if I release this bracket, this 2 will be negative 1 over 9, the ln of sec 3x, then this negative will come there to give me positive 1 over 2x squared plus c. So that's your final answer. If you choose to pull like terms together, you see that there is a negative x squared and a positive 1 over 2x squared. So those are like terms. Half minus 1 is negative half. So that leads us to our final answer being negative a half x squared. When I put this term on this one, then plus 1 and 3x tan 3x, then minus 1 over 9 ln sec 3x plus c. So that's our final answer for that problem. So as we once discussed in the previous video, you realize that whenever you are integrating this, I'm just trying to bring your attention to the fact that there is a method 2 which we call the table method also, or you can call it the tabular method. So we only use the tabular method when in our integral we can confirm that once we bring in elite algebra, we will step in first. So x is our algebra, then this is our trigonometry. So when you study elite, will help you make your choice. You keep seeing that algebra comes before trig as well as before exponential. So once you are very sure that algebra comes first in this abbreviation, then you are free to use the tabular method to save you all the time of doing this calculation. So we'll try to see that method here to see how it works. So with the tabular method, whatever comes first in your elite goes under differentiation, then the other item integration. So here our algebra comes first, therefore our tan square 3x should follow. So algebra side tells you where you end. If I differentiate x, I'll get 1. Then when I differentiate 1, I get 0. So it means here we only have 2 steps. Then when you integrate tan square based on our page number 3, we've already seen here, when you integrate tan square 3x, it gives you 1/3 tan 3x. So I'll get 1/3 tan 3x minus x. Then when I integrate 1/3 tan 3x, don't forget I don't integrate a constant. So the integral of 1/3 tan 3x means I'll capture this 1/3 the way it is. Then when I integrate tan 3x, as we've seen somewhere, or it's on page 2 of the formula sheet, the integral of tan ax is 1 over a, or 1 over a is 1 over 3 ln sec 3x. Then minus the integral of x is simply x squared over 2. So this is our target. So this 1 over 3, sorry, it only affects the first person because 1 over 3 is only multiplied to tan 3x. So that is how our problem will look like, which will therefore end up with this being 1 over 9. So now to break your answers, you just take this and link it there. That's your first arrow. So it means there are only 2 terms and your second arrow which goes with a negative. So your final answer is supposed to get only 2 terms. So let's now capture our answer for the integral of x tan square 3x dx. So our first term means we are multiplying this to this. So we've got x multiplying itself to 1 and 3 tan 3x minus x. That's our first term. Then the second term should be negative because of that. Second arrow carries a negative sign, so that's negative. I will then put that in bracket, then I have 1 multiplying all of that. So when I look at this, the first term is 1 on 9. You can see 1/3 and 1/3 is 1 on 9. Ln sec 3x, then minus x squared on 2. So all that should be covered by the negative sign. Because of that negative on the second arrow, it must apply to all the terms here. So if I now release all the bracket, I'll get 1/3 x tan 3x. This one and this one gives me negative x squared. Then if I open this other bracket, I get negative 1 on 9 ln sec 3x. Then this negative and this one becomes plus 1 over 2x squared, half x squared, yeah, 1 over 2x squared. So this term and the second one are like terms, a half minus 1 over 2. So guys, as I was saying, I'm just trying to do the expansion to confirm that the two answers are the same. So at this stage, you will see that up to so far what we've got, we just need to take this and add to that because these two are like terms. So if I take a half x squared minus x squared, it will give me negative a half. So that will give me negative a half x squared. Once this term and this term are combined, then followed by positive 1/3 x, the term of 3x. Then this is negative 1/9 ln sec 3x plus. So if you compare this answer I've got here to the one I got using the normal method of integration by parts, you see we've got negative a half x squared plus 1/3 x and 3x minus 1 over 9 ln sec 3x. So it's practically the same thing here. Negative 1 over 2x squared plus 1 over 3x and 3x minus 1 over 9 ln sec 3x. So that is just to show to you or to reconfirm that whenever in your product you have algebra coming first in your inlet, if it comes before trig or before exponential, you are free to use the table method to move faster. So in our second example, we'll try to concentrate on the table method, looking at how to integrate 3 minus x multiplying sine square 4x. So it's logical to see that 3 minus x is algebra, then sine is trigonometry. So that therefore means if you want to put it in your inlet, looking at your inlet, you see that algebra comes before trig. So that means we are free to use the table method to go through our process rather than going through the normal process of integration by parts. So with the table method, algebra that comes first should fall under derivative. The trig that comes second falls under integration. So we'll have our sine squared 4x there. Now the part under derivative tells us where we end. So if I differentiate 3 minus x, you know the derivative of 3 is 0, that's a constant. The derivative of negative x gives me negative 1. Then if I differentiate negative 1, it gives me a 0. That tells me where my integration ends. Then for the integral part, the integral of sine squared is on page 3 of the Maths M6 formula sheet. So if I go to page 3 and look at the last 3 formulas, they are showing to me that when I'm integrating sine square ax, if you're looking at the Maths M6 formula sheet, it will give you x on 2 minus sine 2ax on 4a plus c. So matching that to our problem, where there's a, we're supposed to put 4. So if I integrate sine square 4x, I should get my x on 2, putting a there, minus sine 2a, my a is 4, so 2 times 4 is 8x. All that on 4a, 4 times 4 is 16. So that's my integral. Then when I move to the next step, I'm integrating x on 2. Don't forget x on 2 is the same thing as a half x, and we don't integrate constant. We simply integrate the x to give us 1. We multiply by the half, that will give me 1 over 2 minus. If I go here, it's the same thing. When I'm looking at sine 8x over 16, I should see sine 8x over 16 as 1 over 16 sine 8x, which will remind me that I don't integrate 1 over 16, I simply integrate sine 8x. The integral of sine 8x is on page 2 of the formula sheet. When I integrate sine 8x, it gives me negative cos 8x over a. So if I'm integrating this item, I'll get 1 over 16 multiplied by negative cos 8x over 8. That's how the integral of sine 8x will look like. So I'll then multiply that, 16 by 8, 16 is like 2 times 8, so 8 times 8 is 16. 16 times 2 is 128, so this will give me negative 128 cos 8x. So you can use a calculator to confirm that. So it means when I integrate this portion, it will create a negative. This negative combines with this negative, and it becomes a positive 1 on 128 cos 8x. So using my table method, I can now bring out my answer. So in the table method, that is what we do. The first arrow carries a positive sign, the negative carries, the second carries a negative sign, sorry. So if I get back to my problem, I will say the integral of 3 minus x multiplied by sine square sine square 4x dx will be equal to, simply multiply this, so that will give me 3 minus x, it's a term, multiplying another term which is x on 2 minus sine 8x on 16. Then I'm taking this one off, then the second term will be this. You see there's a negative one and another negative, that becomes a positive one, multiplying all of this, so I end up with 1 over 2 plus 1 on 128 cos 8x plus c. So that's how simple my answer is. If I have the energy to open the bracket and pull like terms together, I can do that. If you don't have that energy, usually like that, you have done the essential, which is to multiply, so which is to integrate. So I've just shown you how to do integration by part. That involves algebra coming first and any other function coming later. You can use the table method if you want, or any other method. So guys, thank you very much.